CNC kinematics selection is pretty easy. Monospos developer guides you through step-by-step selections and allows you to quickly define your CNC kinematics in a few steps. Let's define a 5-axis CNC kinematics together. As the first step, you define your CNC as milling, mill turn or lathe. We select milling machine in our example. This time, you have to select the number of axes of your CNC. We select 5 axis. Spindle orientation is the next thing you have to define, either as horizontal or vertical. Let's select vertical. We will describe the difference between horizontal and vertical machines in a few minutes. Selecting the location of rotary axes is an important step. There are 3 alternatives here. Head is used for 5-axis CNCs, with both rotary axes on the head. Head table is selected when one rotary axis is on the head, and the other one is on the table. And last, as can be understood, table means both rotary axes are on the table. We select table now. The last selection is the rotary axis type. There are 2 alternatives here. First is tilting table, and the second is nutating. We will explain the meaning of tilting and nutating terms in a few seconds. In our example, we will select tilting table now. When we make this selection, 2 new sections are displayed on the right. The one in the middle shows the settings for the 2 rotary axes, which are created according to my selections. And on the right, the 3D model of the CNC is shown. This CNC 3D model is automatically created and updated, with your selections on the left. Before going into more detail, let's discuss how rotary axes are named. In order to create a post-processor on your own, you must first know how rotating axes are named. The basic rule is: the axis that rotates around X is A. Axis that rotates around Y is B. And the axis that rotates around Z is C. Let's now explain what tilting and nutating axis means in Monospos Developer. All 5-axis CNCs either have one tilting or one nutating axis as their first rotary axis. The term tilting, or in other words swiveling, is used for rotary axis, which rotates around X, Y or Z. And you can select either of these axes with the A and B axis buttons here. On some machine tool types, you will also see the C-axis button in the tilting settings menu. However, most machines have either A or B as tilting axis. For instance, here in this example, my machine has a tilting axis on table, which rotates around X, and therefore named as A-axis. I can easily change my tilting axis to B-axis. Now, as you can see, the tilting axis is rotating around Y. Let's now explain what nutating axis means. I will create a CNC with nutating axis now. As you can see, the settings menu is different now. Instead of A and B axis buttons, there are I, J, and K vector components here. A nutating axis rotates around a 3D vector in space, instead of rotating around one of the main axes. I can change the vector components here to define the location of nutating axis. Nutating configuration is not very common in the market. Most of the CNC machines in the market have tilting axis. Now let's go back to explaining tilting. Tilting axis can also be on the head. Let's create a head type machine now. This machine has a tilting axis which rotates around X. I can change the tilting axis to B. As you can see, this axis now rotates around Y. Let's now create a head table type CNC. A machine with tilting B axis is created as default. You can easily change this tilting axis to A if you want. We can also create a CNC with tilting C-axis. This is a double column machine with a 90-degree head, with an additional rotary table. It has a C-axis rotating around Z. Let's now explain the second rotary axis, which we shortly name rotary axis, in Monospos Developer. All 5-axis CNC machines have 2 rotary axes. The first one is the tilting or nutating axis, which we have just talked about. The second rotary axis can be on the head or on the table. For instance, this is a head table machine with second rotary axis on the table. Let's create a table machine now. You can see that second rotary axis is again on the table. Let's now create a head type machine. For head type machines, this second rotary axis is located on the head and either rotates continuously or rotates mostly with limited rotation capability. If you have a vertical CNC machine, you should often select this second rotary axis as C-axis. Here in this example, we have defined a vertical machine. Therefore, our second rotary axis is selected as C-axis. However, you can also define the second rotary axis as A or B-axis if you want. For instance, this machine has a second rotary axis defined as B-axis. And now I will create a machine with A-axis as second rotary axis. However, as you can see, A-axis button is not active. This is because tilting and rotary axis cannot be the same axis. Therefore, in order to select A-axis as second axis, I will first change the tilting axis to B. As you can see, this machine has a second rotary axis as A-axis, and tilting axis as B-axis. Let's now create a horizontal machine. Before creating a horizontal machine, I will first describe what vertical and horizontal machine is. Now you see a vertical machine on your screen. A vertical machine has a vertically oriented spindle. And Z-axis is showing upwards. Now I will create a horizontal machine. Let's first create a table type. As you can see, now the spindle is oriented horizontally. And instead of Z-axis, Y-axis is now showing upwards. This is the only difference between a horizontal and a vertical machine. Also note that, on horizontal machines, this second rotary axis often should be selected as B-axis. However, you can also select B-axis as tilting axis. This time I should select A or C-axis as second rotary axis. Let's now create a head table type, horizontal 5-axis CNC. You can see that second rotary axis is again B-axis. The second rotary axis can again be on the head. Let's now show that. I will create a head type horizontal 5-axis CNC. As you can see, this is a head type machine with second rotary axis as C-axis. It also has the A as the tilting axis.